Hello, I'm Rachel Park. I'm here today at the MTC3 Interview Series. Today I am joined by Aaron Frankel from Siemens. Thanks for joining us today, Aaron. So, if you could just start by telling us a little bit about your role at Siemens.
I am responsible for additive manufacturing software solutions at Siemens and Digital Industries.
Okay, so Siemens has a long history in the digital sector and notably with 3D software. How did this evolve over time to specifically include a broader focus on additive manufacturing?
Siemens has been in the business of manufacturing for many years. On the software side, which is where I come from, we've been working on computer-aided manufacturing technologies over the last 5 decades. And we've taken our knowledge in CNC machining and we've invested our energy in CAD and CAE to develop software solutions for additive manufacturing, going from end to end, from idea all the way to shop floor. Siemens as well is also in the business of providing motion control automation equipment and hardware to machine companies to drive CNC machines, but also additive manufacturing machines. We also have factory automation hardware and automation equipment to be able to drive automation on the shop floor. And Siemens is bringing all of these technologies together in order to help industrialize additive manufacturing.
Okay, so there's definitely a huge global push towards digital connectivity. So if you connect that with specifically AM, I know you work with all these other manufacturing technologies as well, but in terms of the digital connectivity and additive manufacturing, how is that evolving at Siemens and how important is it?
Overall, additive manufacturing is a digital technology, and in order to be able to scale up additive manufacturing, we need to be able to have a digital process chain going all the way from concept to finished product, and even taking that finished product into service, and being able to define every step along the way of what has to happen in order to be able to design, simulate, and produce those parts. And in order to do that, we have to have digitalization, we have to have software, we have to have connectivity. And this is a core essence of the solutions that Siemens has been involved in developing and driving forward.
I absolutely get that, and it's true that you have the longevity on the software side, but the company's also a standout for me with additive manufacturing in terms of the way it's evolved. So yes, you have this software element, but you're also a very keen user of additive manufacturing. You provide services and you're also a contract manufacturer. Can you explain how all of this fits together at Siemens?
I think Siemens is in a very unique position in that we offer software, hardware, services, and actually use additive manufacturing to produce end-use products that go into the products that we sell to our customers. And I think that our experience, our involvement in additive has developed in parallel along a number of our different business lines. And what we're doing today is we're leveraging the experience that we have in producing end-use parts and providing services to our customers, providing hardware equipment for automation and software, and we're connecting all those dots. We're bringing all the experience together, and we're developing better solutions as we engage with partners and with industry and with machine companies. And I think this is really where one of the unique aspects of what Siemens brings to the market.
Absolutely, which leads me very nicely to my next question. I visited the Finspång facility in Sweden from Siemens a couple of years ago, and I saw there firsthand how important the internal collaboration is within Siemens and across its different divisions. But how important is external collaboration to Siemens?
External collaboration is...
So, with other partners, in terms of what you're doing, and Siemens is huge and has all these different divisions, but no one company can do all of it, so you're obviously working with other partners. I just wondered if you could tell us a little bit more about that.
I don't believe that we could offer solutions to our customers without collaborating and having a partner ecosystem. And Siemens is investing in building our partner ecosystem in order to bring experience, know-how, solutions, other perspectives on problems in order to be able to offer the market the solutions that we do today.
That's a key one, the problem solving.
Yes, and I think it all comes down to the human connection. I know that we rely very heavily on digitalization, but without the human connection, we would never be able to understand what the problems that other people are actually facing in order to be able to solve them. And Siemens is investing heavily in building relationships with companies and with people who are working with additive manufacturing in order to industrialize it for their uses. We work with machine companies, we work with software companies, we work with companies who are developing applications, service providers, materials providers, in order to best understand what the value of additive manufacturing is and then how to extend that value into the way that we use it and apply it.
I've actually seen that for myself, and going back to Sweden, and I know I keep going back to Sweden, but that's because I really believe that serial production application I saw there, it's among my top personal favourites of additive manufacturing, and that's where I think the key is in the application development. It's really a primary driver for the adoption of AM. It seems to have been the case at Siemens, but what are your thoughts on that particular area and for Siemens, but for the wider industry as well?
I agree. Application development is a key driver to scaling up the use of additive for industrial production. I think that it's really important to, in order to scale additive and scale the number of applications, that we get additive thinking into more minds of designers and engineers. And I think that software plays a key role in that, but I think that also companies need to understand that they need to take additive thinking and push it deeper into their product development and their manufacturing organizations in order to be able to scale up and identify those applications that scale up and provide value to their companies.
Are there any new developments along those lines at Siemens that you are able to tell us about today, or are they pushing on in the power generation division, or is there other areas where things are happening?
Well, Siemens in the power generation area continues to push on. We continue to push on in our services area, but we also continue to work with our customers and our partners in order to push on. And I think a couple areas where Siemens is investing, which I think are quite interesting. One is the automation of designs that perform better than conventional design. So how do we automate the design process in order to come up with geometries of parts that perform better than what we could have manufactured conventionally?
You're talking about generative design?
I'm talking about generative design.
Yeah.
I'm talking about lattice design advisors.
Okay.
And helping engineers, actually enabling engineers to define the problem space, define the objectives that they want to achieve, define the boundary conditions, and then let the computer do the hard work in determining what is the ideal geometry for a part that's going to achieve those objectives.
Okay, so when you say the ideal geometry, let's just dig down a little bit there, because are you talking about saving weight, saving materials, or? Improved
thermal conductivity,
okay.
Improved thermal management, improved flow. All the combinations, a multi-physics approach to improve structure, flow, thermal dynamics, okay, are all areas that we're investing in.
I think this is really important because some people that I've spoken to, sometimes they think this whole constructing lattices with AM is just a gimmick. It's just to show off the technology, but actually there's a real function to it.
Absolutely. In our Finspång facility, bringing it back to Sweden, is developing applications that have lattices within them in order to better manage the heat of many of these parts that we're putting into our gas turbines. So that's one area that we're investing. We're also investing heavily in process simulation. So how can we predict the outcome of the AM printing process and then be able to compensate the design for any distortions that we may have predicted?
And I guess that all helps with traceability of the process and in-process monitoring and quality control as well?
It will help with that.
Yes.
It'll also help with printing first time right. So
Okay.
it'll give us that added confidence that the design that we're actually going to send to the printer is going to be produced the way that we expect it to.
Are there any key issues you still think are missing, either on the digital side or on the hardware side? Where do we still need to work hard?
Where do we need to work hard? I think we need to work hard on the shop floor. I think that we need to work hard on having interfaces between machines and the digital backbone. I think that we see a lack of standards in this space. I think there's a lack of APIs or interfaces that are common across the different equipment manufacturers.
Definitely agree on standards.
And
people are crying out for them, aren't they?
Right, and in order to be able to bring additive manufacturing off of the island and into the mainstream manufacturing operation, we need to be able to connect that equipment and be able to deliver data to it, be able to take status information off, be able to collect pools and streams of data that we can then analyze and use that information to help us, certify quality or ensure quality, for example. So I think the standard is a very important area.
It feeds into the validation process as well, I guess.
Absolutely.
Particularly for the power generation industry, because that's huge, like aerospace and automotive and medical. That the validation process is as important almost as the...
I think the validation process is almost as important as the design that we end up creating. If we can't validate that we created the intended design, then we didn't really end up with what we expected, yes.
Absolutely.
And having that digital connection and that closed loop is going to enable us to be able to get there.
Fantastic. Yeah. Okay, so just to finish off, what are your goals as a company, Siemens, for additive manufacturing in the longer term?
We're on a mission to industrialize additive manufacturing in order to help companies be able to design and produce useful applications and parts in large volumes. And this is something that we're going to continue to drive, and we believe that it requires a digital thread in order to do that, and this is what we're going to enable.
Amazing. Thank you so much for your time today, Aaron.
Thank you.